Hi everyone, so in today's video I'm going to speak about completing the square or complete the square. Now, it will sound a bit strange, like what does it mean? First thing, we need to remember what we mean by a square, because it's not actually, it is related a bit to geometry and the area of a square, which are two things multiplied together, or the same thing squared. And that is actually the issue. So when we speak about algebra, we have, again, when we look about the square, we think about the area of a square, and we have like 3 squared, so 9 is a square number. But we also have x plus 2 squared. That's also squared. It's still part of squaring something. And this is x squared plus 4x plus 4. So this is a complete square. Like, we know it gets to a bracket squared. And that's what we're going to be looking for today. We're going to see if we can change any type of expression that has an x squared to a complete square. So before I go on and do that, I have to write a formula that we've actually got when we multiplied brackets, or when we expanding brackets. So I will put that video in the corner up there. When we had a plus minus b, everything squared, our formula was a squared plus, if we had a plus, or minus if we had a minus, 2ab plus b squared. So this is what we're going to be looking at. We're going to try and make every single expression or trinomial that has something squared at the start into a complete square. So I'm going to go with the first example. We've got x squared minus, or let's not put a minus from the start, let's put plus x minus 13. Now this is not a completed square. It cannot be written as something plus something else squared. It just does not have this idea. It has something squared. It looks like it has 2 times something in here, because it looks like it has 2 times 4 times x, but it doesn't have a b squared. It just has negative 13. So this already is not a square. So this is not a square. Now obviously we don't really see not a square because it does look a bit strange, but just for you to get an idea of what I'm speaking about, this is not something, an expression squared, so it's not a square. But it looks like the first part of this one could be, so this actually could be part of a square. So again, I'm just very careful about this. It's not, so don't think of this as an actual square. So I'm putting it in a bracket. It's like the way you can think about it. Now, I want to rewrite this one a bit so I can actually see the 2 parts in there. So I'm going to rewrite this. And I'm going to write that as x squared plus 2 times 4 times x, and then I'm still going to put the minus 13. So I've looked at this one. Now in my formula there, I do have the little 2. I have an a and a b, so it looks like my a could be the 4 and my b could be x. So I can get a bracket squared. The way I get the bracket squared, and it works for absolutely every single situation like this, it has to have the x first, because I'm going x squared. And then whatever number I have here, I always need to divide that one by 2 to get what I have here. This is 2 times 4 divided by 2, that gives me 4. Then I look at what sign I have and I put plus. So this is x plus 4 squared. This is a squared because this is part of this squared. But is this all of it? do I just need to do anything with it? And I'm actually going to multiply this one on the side for you to see. So this is x squared plus 2 times 4, 8, so 8x, plus 4 squared, which is 16. So looking at this, I do have the first two, but I do have this 16 here, which is actually extra. So I'm thinking of this as an extra. This I have in the question. This I have in the question. This I don't. It's just an extra bit. So because it's an extra bit here and it doesn't appear there, I will just take it away. Because it's extra, which means I don't need it. It shouldn't be there. I just need the first two terms. And then I copy the negative 13 on the top, just because I haven't done anything with it. And then I'm gonna tidy things up. So this is x plus 4 squared minus 29. Now, this is completing the square. I have completed the square. And it does look a bit, what have you done? You've completed what square? I've changed this one to a completed square. That's what I've done. I've changed it. I've just said this is a completed square. I've completed the square. I've got a square and something else after that. So it does look a bit strange. Now, if you want to do a check to see that you've got to this side, you are free to do it if you want to. I actually want to try it and do it on the side just to show you. So we've got x plus 4 squared minus 29. So I've got x squared plus 8x plus 16 minus 29. So it gives me exactly what I started with. So I've done the calculations correctly. That is good. And this whole bit is actually helping us so much when we want to draw the graph of this function. It's gonna be way easier. And I am going to get to drawing graphs at one point as well. I do want to do videos on that, and hopefully you will see the use of that when we start drawing graphs. But this is it. It does sound a bit counterintuitive, but it's just another way of rewriting the expression over there and trying to make it related to something squared. Now, if you want to think of this as like a general formula, just from the fact that we start with something like that, there is a way of thinking of this as a formula. I think I want to put it in like a little bit of a bracket there, because it does look a bit strange. So it's always in your bracket, you're going to have this divided by 2. So that's why I've put this. And then always you're taking away the a squared, and then you copy whatever you had on the top. So that's kind of the formula. It works in any type of situation where you don't have a number in front of x squared. So if you want to be a bit fast on that, that's the fast way. But yeah, it's pretty straightforward. So I'm going to give you another example for this one, if you just want to use this. So we've got minus 6x plus 8. So I'm looking at, this is a 2 times 3, so this should be x minus 3 squared, and then I take away the 3 squared, 9, and I just copy the 8, and it gives me x minus 3 squared minus 1. And I rewrote it with a completing the square in the front over there. So that's us done. Now the issue comes when we have a number in front of the x squared. So let's go with 3x squared. I need to be a bit more careful with this example. Plus 36x minus 13. Okay. So the first thing is, when I look at the first two, and I always look at the first two because they're the ones that give me whatever bracket I have squared. I have an extra 3 there. That's so annoying because it's not a 9, so I can't put it in the bracket. It's just a 3. So to make sure I don't think about it, I'm actually gonna take it as a common factor and see what I have left. So this is what I've done, and now I have the 2 bits that are going to give me the squared, but I always need to not forget the 3 in front. So I've got the x plus 6 squared, and I normally take away the 6 squared, which is 36, but I have to be very careful. I've just done this, so 3 was in front of my bracket, so 3 is in front of all of that, so 3 is in front of this. That's the bit I need to be very careful, because now to make sure I clean things up here and I just have something squared is to actually multiply the 3 by 36. So that's the bit of that's the issue, if you want to call it an issue. Yes, it took me a second. So this is 121. So this is me completing the square. I've got the squared here, I'm taking away something, and I've got the 3 in front that will give me the 3x squared. I can do a check if you want to, but it's still the same thing. The most important bit over here is to actually do the common factor. Because if we don't do the common factor, we won't actually be able to do this. We won't get the bracket squared. So yeah, sometimes, very rarely, we call it a forced common factor, because it's not going to be a factor of this one, but I don't want to confuse you too much. But that's the first thing, and it could get a bit confusing when we have something like that, but it does really, like, honestly help tremendously trying to complete the square in this type of situations, especially when it comes to drawing the graph and finding little bits about the graph of these expressions. So yeah, I'm sure, again, this is another method. I'm sure people are doing it a bit differently, so just let me know in the comments if you do it differently. Also, if you've never ever used it before, I would actually be curious as well, because I haven't used it for years, and then I saw it as someone trying to do the graph of something like that, and I was like, oh wow, this makes sense, and it does help with the graph. So that's how I first saw it. So I haven't seen it for years, and then someone showed it to me and I was like, ooh, useful. So I've kept using it whenever I had the chance to do that. So yeah, let me know if you have any questions, or if you've used this before, or if you use it any differently, if you do it any differently, and I would love to know. Have a lovely day, and I will speak to you soon. Bye.